let's proceed with some more important questions. In this question, again, if you observe, the entire plane lamina has been kept in the first quadrant. That means we are least concerned about the signs of the x and the y coordinates of the centroids, isn't it? Since the entire plane lamina lies in the first quadrant, we can be very much assured that the x and the y coordinates of all the centroids for the standard shapes is going to be positive. So students, identify this particular question first of all. It's a very typical question. You need to think about the question for a moment. If you observe, for this particular question, if I want to find the area of the centroid of the shaded region, observe carefully. I can take a very big triangle over here. Observe from this BD, it has been extended such that it goes and meets at point A. So it is actually length AB. Line AB is one intact line. So if you observe, you can take a very big triangle OAB, isn't it? You can take a triangle OAB, and from this triangle OAB again, you can add this triangle ADC. So let's add the triangle ADC, and from these two triangles, the summation of these two triangles, you can subtract the quarter circle OEF minus of quarter circle OEF. That is the strategy of solving the question, isn't it? You take the big triangle, you take the small triangle. So the two triangles you join, you get the entire plane lamina over here. From this entire plane lamina, you cut the quarter circle. You get the required or the desired shape, the composite shape that we have. Now my bigger challenge is to identify what is length of CD. Now most of the times I have seen students telling me that the length of CD is 20 centimeter. Observe carefully. In the diagram, it might sometimes look like F and D are just one above the other. So people confuse the length of CD with 20 centimeter, but it is not the length of CD as 20 centimeter. You got to understand this thing very carefully. Observe carefully. From anywhere, can you say that this OF and this ED are of same length? Anything has been mentioned about this particular comparison? OF, ED, CD, AF, anything has been mentioned about the comparison of these lengths? You cannot simply look at the diagram and tell that the lengths will be equal. No, you need to have a strong reason if you want to say that AF and CD are of equal length. So my friends, they are not of equal length. Observe what I'm doing here. I'm going to get the length of CD. Now, if I join this ED also, you can observe there are two triangles now, isn't it? So let's remove this. I don't need this stuff. I have already strategized the entire question. Now observe carefully. I can see that there are two triangles. Triangle BED, triangle BED. Now observe carefully. This D is vertically opposite with this D. Then this is the right angle E with the right angle C. Then one vertex that is left is A. Also this angle B will be common to angle A. Look at this, they are forming pairs of alternate angles. So BED will be same as ACD. So this is similar to triangle ACD, isn't it? Both the triangles are similar triangles by the angle test. Or you can say there is one right angle and then there is one angle. So there is a right angle and angle test. So triangle BED is similar to triangle ACD. That means should the sides be in proportion? Students, the sides will definitely be in proportion. So observe carefully. I would take this BE. This is BE. So upon you get AC, isn't it? So I get DE upon AC. This becomes equal to ED upon CD. I am interested in the length of CD and ED. So nowhere it is mentioned that point D is the midpoint of EC. So you got to be very careful with this. And now you are going to see that they are not equal also. So I will take this ED. This is ED upon CD. So I write here ED upon CD. Now let us assume that the length of CD I am going to take as X. Let us the length of CD is taken as X. So if this is X, I know total distance was 40 centimeter because I know that the radius is also 20 centimeters. So the total length becomes 40 centimeter. So if this CD is taken as X, what can you say about DE? So DE will become 40 minus X. Isn't it? This is 40 minus X. So I can say BE upon AC, BE which is 30 upon AC which is 20 is equal to ED. What is ED length? It is 40 minus X. 40 minus X upon CD, that is X. This is X, so the 0 and 0 will cancel. You get 3 and 2. You just do the cross multiplication. So you get 3x, isn't it? 0 and 0 is cancelled. 3x is equal to 2 into 40, that's 80 minus 2x. That means you get 5x is equal to 80. So you've got x as 16. So did you observe that the length of CD is not 20 centimeter? It is coming 16 centimeters. So this is 16 centimeter. So now what I'm going to do, I take the bigger triangle, the smaller triangle, the bigger triangle plus the smaller triangle minus the quarter circle. I will easily get my answer for the centroid of the composite shape. So let's begin with the calculation, students. So I'm going to take the very first diagram, which is a right angle triangle, the very big one, triangle OAB. So I take the first standard shape, which is a right angled triangle, isn't it? Let's draw the right angled triangle. I take the x-axis, I take the y-axis, and what is the dimension of this right angle triangle? This base is 20 plus 20, that's 40, and the height is going to be 20 plus 30, that's 50. So that's 50 and 40 centimeters. So I take the right angle triangle over here. This is the right angle triangle. The base B is going to be how much? The base is going to be 20 plus 20, that's 40 centimeter. So base is 40 centimeter. What about the height? Students, the height is 50 centimeter. So H is going to be 50 centimeters. I know for a right angle triangle where the centroid lies, it lies at 1/3 distances from the perpendicular sides. So you draw a line parallel to this perpendicular side and another line parallel to this perpendicular side, such that the distances from the perpendicular sides is 1/3. So this is H. Total length is H. So this becomes H by 3. This total length is B. So this becomes B upon 3. Now, this is the centroid, isn't it? This is centroid G1. So I need to find the horizontal and the vertical distance, the perpendicular distance of the centroid from the original Y and the X-axis. So that's the Y-axis. The distance from the y-axis is going to be what? It is going to be x bar. So this is x1 bar. So again, I'm using the small letters here now, students, because I've not made use of the concept of shift of origin. The entire plane lamina is itself lying in the first quadrant, so I need not have to worry about anything. So that's x1 bar. This is going to be y1 bar, isn't it? So now let's very quickly find first of all area A1. So what is the area A1 going to be? The formula is half into product of perpendicular sides, isn't it? The perpendicular sides are of what length? It is 40 and 50. So I get 1 upon 2, 40 into 50. So 1 upon 2, 40 into 50. So this 4 and 2 can be cancelled. You get 20. So 5 2s are 10 and the 0 zeros. So you get 1000 centimeter square. That's A1, isn't it? Now let's very quickly find x1 bar and y1 bar also. Students, what is going to be x1 bar? X1 bar is going to be this distance B upon 3. B upon 3. So B is 40. So it becomes 40 upon 3. And what about y1 bar? So y1 bar is going to be, this is h upon 3, so that's 50 upon 3, h upon 3, so I get 50 upon 3. So I've got x1 bar and y1 bar. So that was all about the right angle triangle. Now let's take the second right angle triangle. Now you would need to be very careful, students. Look at the position of the right angle triangle. This length is 40 centimeter. So your right angle triangle corner A is placed at a distance of 40 centimeter. What about the height? It is 20 centimeter. What about the base? It is 16 centimeter. So I take the second right angle triangle now, and you draw the diagram at an exact position with respect to the original x and the y axis. So this is the x axis, this is the y axis, isn't it? I want to draw the perpendicular side of the right angle triangle at a distance of 40 centimeter. So I will take here, let us say this is the perpendicular side, one of the perpendicular side of the right angle triangle. This length is 20 centimeter and this length is 16 centimeter. So I take here, this is 16 centimeter, isn't it? So this is 16 centimeter and this is 20 centimeter, and you join the hypotenuse as well. This is your right angle triangle which is placed, isn't it, with respect to the original x and the y axis. Now, I know I'm going to call this B 16 centimeter and this 20 centimeter as H. So again, remember that the centroid will always be at distances of 1/3 from the perpendicular sides. So this is one of the perpendicular side, this is the other perpendicular side. You draw lines which are parallel to these perpendicular sides. So this is going to be the centroid, so call it as G2, such that the distance of this centroid from the perpendicular sides, so this is parallel to B distance, so this is going to be B upon 3. This distance is parallel to H, so this is going to be H upon 3. This is H, so that becomes 1/3 of it, so H by 3. So now students, I want to get the position of the centroid with respect to the original x and the y axis. So this is x axis, this is y axis, so original x and the y axis. So let's draw the two perpendiculars. So this is going to be x bar, this is the distance of the centroid from the y axis, so this is going to be x2 bar, and this perpendicular distance is going to be y2 bar. So is x2 bar b upon 3, is y2 bar h upon 3? The answer is no, isn't it? H by 3 and b by 3, these are the distances of the centroid with respect to the perpendicular sides of the right angle triangle, isn't it? It is not always it is x bar and y bar. So here, what is x bar going to be? So first you tell me what is the total distance here. This total distance, if you recall, the total distance was how much? The total distance was 40 centimeter. This is 40 centimeters. So can you say x2 bar is going to be this 40 centimeter minus b upon 3, isn't it? This 40 centimeter minus b upon 3, that will give me x2 bar. And look at y2 bar. Students, if this distance is h by 3, you can easily tell that the rest of the distance from the apex, the vertex, you can say, it is going to be 2h upon 3. So is y2 bar 2h upon 3? Very simple it is, isn't it? So you need to have this idea of the position of the centroid with respect to the perpendicular sides and with respect to the vertices of a right angle triangle. So I'm going to get the area first of all. So here also the formula is going to be same, half into product of the perpendicular sides. Who are the perpendicular sides this time? 16 and 20. So 1 upon 2. 16 and 20, so this 20 and 2 cancels, you get 10 into 16, so that's 160 centimeter square. That is nothing but what? That is your answer for the area of the second triangle, isn't it? Now let's get x2 bar very quickly. So x2 bar is going to be, total distance is 40 minus b upon 3. So 40 minus b upon 3. So b, I know it is 16, so it is going to be 16 upon 3. So let's do that calculation in a short while from now. And then y2 bar, students, what is y2 bar going to be? It is going to become 2h upon 3. What is h? H is 20, so 2 into 20 upon 3. So 2 into 20 upon 3. So that's simply going to become 40 by 3, isn't it? So I've got y2 bar and x2 bar and a2 for the second standard shape. Let's take the last standard shape now. The last standard shape is a quarter circle, and look at the quarter circle, very simple. It is directly having both the radii lying on the x and the y axis, isn't it? The radii of the quarter circle are straight away lying on the x and the y axis. So I did not think about x bar and y bar. It is definitely going to become 4r upon 3 pi. So let's take the third standard shape, which is a quarter circle. So students, I take the x-axis and the y-axis and I simply make a quarter circle with both the radii lying along the x and the y-axis. That's your origin, isn't it? Now, what are the radius given to us? The radius is 20 centimeter here for the quarter circle. So the radius r is 20 centimeter. Radius r is 20 centimeter. Where does the centroid for a quarter circle lie? It will lie at distance 4r upon 3 pi from the two radii, isn't it? So I take this distance, I take this distance here, 4r upon 3 pi, the distance of the centroid. This is g3. So this distance is 4r upon 3 pi, and the other distance is also 4r upon 3 pi. And these distances are actually the distances from the y and the x axis. That means definitely this is x3 bar and this value is y3 bar, isn't it? And radius is 20. So very quickly I'm going to get the area first of all. So it's a quarter circle. So I know area is given by pi r square upon 4. What's the radius, students? The radius given to us is 20. So I get pi into 20 square upon 4. So I write here pi into 20 square upon 4. So that's 20 into 20, isn't it? So 20 and 20 and 4 is 2 into 2. So you get 10 and 10. So 10 square is 100. So my answer is here 100 pi centimeter square, isn't it? So you can make use of units everywhere. This is all in centimeters. So I'm going to get this x2 bar. This is 40 upon 3 centimeters, y2 bar. So students, now let's get x3 bar and y3 bar. They are both same, isn't it? So x3 bar is going to be 4r upon 3 pi, and I know radius is 20. The value of radius is 20 centimeters. So you get 20 into 4, that's 80 upon 3 pi. So you can write here 80 upon 3 pi centimeters. No need to do the calculations further. You can leave the answer over here itself, isn't it? And then y3 bar is also going to be 4r upon 3 pi, which is again going to come 80 upon 3 pi centimeters. Now, after I get all these values, now I need to get what? X bar and y bar, and I know the formula is summation of ai xi upon summation of ai, and for y bar it is summation of ai yi upon summation of ai. So both these formulas are requiring the value of summation of ai. So let's quickly get summation of ai, students. So here summation of ai is going to be a1. The first area has to be kept, the area of the right angle triangle, the bigger one, plus a2. The second right angle triangle area also has to be kept, a1 plus a2, but the quarter circle needs to be removed. So a1 plus a2 minus of a3. So what's the value of a1, students, that you have? It is 1000 centimeters square. What about a2? It is 160 centimeters square. And what about a3? It is 100 pi centimeter square. So I need to get the value over here. I'm going to make use of a calculator again over here. So let's very quickly get the answers. It is 1000 plus 160 and minus 100 pi. So the value comes 845.84. So I'm going to write my answer over there. It is 845.84. 845.84 centimeters square. That's the value of summation of ai. Students, let us get the value of this x2 bar also, because it is 40 minus 16 upon 3. So you get 40 minus 16 upon 3. The value comes 104 upon 3, or you can say 34.66667. So I write this value as 104 upon 3. So let's write 104 upon 3, isn't it? Now, once I get these values, the next thing that I need to do is to find the value of what? X bar and y bar. So let's write the calculation for x bar, y bar very quickly. So x bar is going to be summation of ai into xi upon summation of ai. So summation of ai xi, so that's a1 into x1. That's 1000 into 40 upon 3, isn't it? 1000 into 40 upon 3, so that's a1 into x1, then plus the second area is 160, isn't it? So 160 into x bar is 104 upon 3, so that's 104 upon 3, and then minus, because we're going to subtract the third area, so that's 100 pi. You write here 100 pi multiplies with its x bar, it is 80 upon 3 pi. That's 80 upon 3 pi. That's the reason I have not cancelled or I have not simplified that 80 upon 3 pi. You can easily see that this pi and pi can be very easily cancelled, isn't it? So that's 100 into 80 upon 3, and this entire thing gets divided by the summation of ai, which is 845.84. So I'm going to do this calculation in a short while. Let's get the value of y bar also. It is going to be summation of ai into yi upon summation of ai. So let's do this summation of ai yi, students. I have this again 1000 into this time 50 upon 3. So I write here 1000 multiplies with 50 upon 3, then plus 160 multiplies with what's y2 bar? It's 40 upon 3. So I write here 40 upon 3, then minus, I have the area of the quarter circle as 100 pi, isn't it? So this 100 pi multiplies with again y3 bar is 80 upon 3 pi. So I write here 80 upon 3 pi. So you can easily say that the pi and the pi is going to get cancelled, and in the denominator I know there is going to be summation of AI, which is 845.84. So again, let's quickly take the calculator and find the values. So students, let's get the value of x bar. First of all, be very careful while doing the calculations. You have to be very attentive while doing the calculation. Look at the numbers, look at the signs, and only then get your answer. So that's 1000 multiply with 40 upon 3, then plus 160 into 104 divided by 3, then students minus 100 into 80 divided by 3. That's my numerator. This needs to be divided by 845.84. So the answer is coming 19.16832. So I can write my answer as 19.16832 centimeters for x bar. And let's get the value of y bar also, students. For y bar, again let's do the calculation. Again, be very careful. That's 1000 into 50 divided by 3, then plus 160 into 40 divided by 3, minus 100 into 80 divided by 3. You get some answer. This answer needs to be divided by 845.84. You get your answer as 19.07374. So my answer here is 19.07374 centimeters. So that's x bar value and that's y bar value. So students, in this question you have observed that by looking at the diagram you cannot judge or you cannot decide the values directly. You need to have a very strong reason if you want to tell any of the dimensions over there. So sometimes a little bit of geometry also gets involved while solving the question. So make sure that you're also very good with your geometrical part. So students, that was all about this particular question. We are again going to proceed ahead with some more important questions.